Hello class, in this video I'll be going through the solutions for solving linear equations and literal equations revision worksheet. So for the very first question, I'm going to be asking a series of linear equations that I'm asking you to solve. And remember, when I asked you to solve, I referred to the FUCK method as a tool that you could actually use to guide your working out and thinking process so that you can actually solve for the unknown letter. So for the very first question, it reads 9y minus 5 is equal to 30. So we don't have any fractions, so we don't have to worry about that step. We don't have any brackets, so we can ignore that step. And step number 3 says you want to chase away any pluses and take away signs, and we do that by using inverse operations. So notice that you've got a minus 5 over here next to the letter. So what we want to do is you want to move that away to the other side of the equation, and in doing so we're going to use inverse. So the inverse of negative 5 is going to be plus 5, so I'm going to plus 5 to both sides of the equation. So negative 5 plus 5 equals 0, so they cancel out. So therefore 9y is going to be equal to 35 now. And to now do the last step, what I want to do is I want to divide both sides by the coefficient being 9 in this example. So by dividing both sides by 9, well, 9 divided by 9 is 1, so that cancels each other out. And in this case, 9 can't go into 35 exactly, so your answer is just going to become 35 over 9. We don't have to use a calculator to get to a decimal, or not necessary. For question 1b, notice that this time you've got a fraction. So what we're going to do first is we want to try to get rid of the fraction by making sure all terms have the same common denominator. But before I do that, what I'll do is let's move this guy away to the other side. So to get rid of plus 2, I'm going to do the opposite. So I'm going to subtract 2 from both sides of the equation. So by doing so, that cancels each other out, and you're left with this over here. So 3 minus 2 is equal to 1. So again, now that I've got the fraction, I'm going to make sure that all terms have the exact same common denominator. So to do so, you would agree with me that the number 1 on the right hand side of the equation can be expressed as a fraction. That's the same thing as writing 1 over 1. And in this case over here, your lowest common denominator is going to be equal to 5. So let's make the denominator equal to 5. So to do so, what I'll do is I'll just multiply that by 5 on 5. And so therefore, the equation should now look like this. Now notice that your denominators are not the same. Because your denominators are the same, what that would imply is that your numerators must also be equal to one another as well. So what you can do is you can cancel out the denominators. So by cancelling out your denominators, what you're going to be left with is just x plus 4 is equal to 5. So what I've done is I've essentially cancelled the denominators. And now that's in this particular format, it's a lot more easier for me to solve. So to solve for x, I'll now subtract both sides by 4. 4 minus 4 is equal to 0. That cancels out. Hence, my answer is going to become x is equal to 1. For question C, I've got variables found on both sides of the equation. And generally, we like to keep the x's or the letters on the left-hand side. So what I'll do first is I'm going to get rid or cancel out the 3x by subtracting 3x from both sides of the equation. So therefore 7x minus 3x is going to be equal to 4x, and I'm just going to drop everything down, so therefore that becomes minus 5 is equal to 11. Now what I'll do is I'll get rid of the negative 5 and bring it to the right hand side of the equation, and I'll do that by using the opposite. So the opposite of negative 5 in this case is positive 5, so I'll add 5 to both sides. This will cancel each other out. So therefore, it will become 4x is equal to 11 plus 5, which equals to 16. And for the very last step, what I'm going to do now is I'm going to kick off the coefficient by dividing both sides by 4. So by dividing both sides by 4, that will get cancelled out because 4 divided by 4 is equal to 1. Hence, x is going to be equal to 4 as the answer. For question D, you've got algebraic fractions. So again, what we want to do is you want to make sure that the denominators are the same so that we can kind of cancel things out. So the lowest common denominator in this particular example over here is going to be equal to 20. So to make the denominators equal to 20 for the first fraction, I'll multiply this by 5 on 5, and I'll multiply the second fraction by 4 on 4. And by doing so, the denominators are going to be the same. So if I do this, this would now become 5 bracket 3n minus 1 is equal to 4 bracket 4n plus 1, and everything is now over 20. Remember, when the denominators are now the same, we can just equate the numerators. So I'm just going to cancel this out over there. So that essentially just becomes 5 bracket 3n minus 1 is equal to 4 bracket 4n plus 1. And now I'll expand both sides. So 5 times 3n is going to equal to 15n. That's minus 5, 16n plus 4. We want to keep the letters on the left-hand side generally. So I'm going to bring 16n to the other side by subtracting both sides by 16n. So that will cancel that out. So 15n minus 16n is going to be equal to negative 1n. And to get rid of the negative 5, I'll add both sides by 5. Cancel, cancel. So now I'm left with negative n is equal to 4 plus 5, which is equal to 9. And because we want it to have a positive, not a negative in front of the letter, we'll just divide both sides by negative 1. So that essentially just flips the sign. So therefore, in this case over here, n is going to be equal to negative 9. So that's just a therefore symbol. All right, and for the very last question, for question 1, same concept applies. Find out what is the lowest common denominator. So what I'll do first is I'm going to express this as a fraction first. So that could be written as x over 2 plus x on 3 is equal to 10 over 1. And in this example, the lowest common denominator is going to be equal to 6. So I'll multiply that by 3 on 3. I'll multiply the second fraction by 2 on 2. And I'll multiply 10 over 1 by 6 on 6. And if you do this, the denominators are now going to be the same. So this becomes 3x on 6 plus 2x on 6 equals to 60 on 6. Remember, denominators are the same, so you can cancel them out. So I'm just going to rewrite that. So that becomes 3x plus 2x is equal to 60. I can now add these together. So 3x plus 2x is going to be 5x. And in the last step, I'll divide both sides by 5. Hence, x is going to therefore be equal to 12. Questions 2 and questions 3 are solving literal equations. So literal equations are essentially equations where you have 2 or more letters. And when you're trying to solve for a particular letter in a literal equation, some of the tips that I recommend is A, you want to make sure that the letter that you're trying to solve for is on the left-hand side of the equation. So if the letter you're trying to solve for is on the right-hand side, what you want to do is you just want to flip the equation so that that letter is on the left-hand side. And then all you need to do again is just use inverse operations to isolate that particular letter. So let's go through these 3 questions here. So you're trying to solve for x. Notice that x is already on the left-hand side, so I don't need to do any switcheroo, any flipping. So we're going to now use inverse operations to solve for x. So what I'll do first is, because I can see there's a 2y, let's get rid of that guy first. So the opposite of positive 2y is by subtracting it by 2y on both sides. So that's what I've done over here. 2y minus 2y is 0, so that cancels out. So what you're left with now is negative x is equal to 5 minus 2y. And because you've got a negative in front of the x, what we want to do is we want to get rid of that. So we'll essentially divide both sides by -1. And remember, by dividing both sides by -1, that just changes the sign for the numbers. So positive 5 now becomes -5. And negative 2y now becomes positive 2y. For question B, it reads y is equal to 2 bracket x plus z close bracket. Notice that x in this case is on the right hand side. So what we want to do is make the x or the letter you're trying to solve on the left hand side. So let's just flip the equation over around. So therefore that becomes 2 bracket x plus z is equal to y. Now there are two ways that you can solve this question over here, but I recommend in this example over here, please do not expand it. And the reason why that is because when you expand numbers, generally speaking, you make it more complicated, more complex, because generally speaking, you make the numbers larger if you're dealing with numbers. So to make your life easier and to show less steps overall, I recommend you divide instead. So one of the ways that we can get rid of the 2 outside is by dividing both sides by 2. So that will cancel out as so. So what you're left with is on the left hand side is just x plus z, but now that is going to become y divided by 2, y over 2. And now to solve for x, all you need to do now is just to get rid of the z. So because that's plus z, we'll get rid of it by subtracting both sides by z. By subtracting both sides by z, your final answer is now going to be x is equal to y over 2 minus z as the answer. And for the last question, for question 2, you're trying to solve for x. Notice x is on the right hand side, so let's flip the equation first. So for the very last question, notice that x is on the right hand side, so let's flip the equation first. So by flipping it, it's going to become L plus 3x on 2 is equal to R. And so now what we're going to do is we're going to get rid of the divide by 2, so that denominator over there. And the way that we do that is by multiplying both sides by 2. So if you do that, it's going to become L plus 3x is equal to 2R. To get rid of the L, we will subtract both sides by L. So that would cancel out. So what you're left with is 3x is equal to 2R minus L. And to get rid of the 3 in front of x, because that's saying 3 is being multiplied by x, we divide both sides by 3. Hence, our answer is now going to become x is equal to 2R minus L, all divided by 3. For question 3, we're trying to solve for literal equations again. But for this particular type of question over here, there might be one extra thing that you might want to be mindful of. And over here, that's just this part over here. So for some questions, it might actually be useful to show any multiplication signs at all. So this is kind of applicable for the very first question. So you're trying to solve for h. So we're going to do the exact same thing where the letter you're trying to solve, keep on the left hand side. So let's flip the equation. So it therefore becomes half times b For question 3, again, we're going to be solving literal equations, but this question is slightly different from the other question, and I've also included this step over here. So sometimes it might be useful for us to indicate the multiplication sign because it might help us reach our final answer. So for question 3a, you're trying to solve for the letter h. Notice that h is on the right hand side, so I generally like to keep h's on the left hand side, so let's flip the equation over. So if I was to flip the equation, this is what the equation would now look like. But I've also stated that it might be helpful for you to include multiplication signs. So I'm going to rewrite this in a different manner. So half BH is the same thing as writing B times H divided by 2 is equal to A. That's the exact same thing, right? I've just rearranged it and put it in a very slightly different manner, but they both have the exact same meaning. And you're trying to solve for H. So what we can do is let's get rid of 2, the denominator, by multiplying both sides by 2. So if you do that, it becomes B times H is equal to 2A. And to get rid of the B, because B is being multiplied by H, we just divide both sides by B. And so therefore, our answer is going to be H is equal to 2A divided by B. For question 3b, you might need to do something very similar. So you're trying to solve for the letter R. Notice that R is on the right hand side. So let's flip the equation. So it becomes, pi times R squared is equal to A. So remember that sign in between this is a multiplication. We're trying to solve for R. So let's get rid of the pi symbol by dividing both sides by pi. So therefore you're left with is R squared is equal to A divided by pi. And to get rid of that little squared sign, the inverse of a square is the square root. So by taking the square root of both sides, that gets rid of that over there. So hence your final answer is going to become R is equal to the square root of A divided by pi as the answer. And for the very last question, you're trying to solve for the letter L. L is on the right hand side of the equation, so let's flip the equation. So therefore that would be the same thing as writing n bracket A plus L close bracket all divided by 2 is equal to S. So now let's get rid of the denominator 2 by multiplying both sides by 2. So therefore that'll become like this. What we could do is we could expand, but a better way is actually by dividing both sides by n, because we're trying to solve for L in this case. So by dividing both sides by n, that will get rid of this. So therefore it will become A plus L is equal to 2s divided by n. And what we'll do now is we'll subtract both sides by A. So that will cancel that. So therefore your final answer is going to be L is equal to 2s over n minus A as the answer. Alright guys, that's the solutions for all these 3 questions over here. Hopefully this has been helpful. Thank you for watching the video, and I'll see you guys again in the next video. Bye.